Okay, so let's start. We're gonna do chapter 5 now. So we'll do two sections, 5.1 and 5.2. So here's section 5.1. There's really only one type of question from this section I kind of want to talk about.
Excuse me, sir.
Yeah.
My brother's away right now. I don't want him to miss out on any of the math. I don't know what you're gonna do about it, but maybe like,
Sorry, what's the problem?
Right now, there's a hot that's in danger.
where is it?
Front yard.
Hello?
Hi, everybody.
Manager, who's awake?
For people squeeze.
Okay. Anyway, well, this video is being recorded, so we can just kind of like watch the beginning part over again. Anyway, so we're mainly going to focus on the problems. So this is from 5.1, like 45 to 60-ish. But so this whole section is about inverse functions. And so, we have an equation, f of x, and then, we plug in an x value, and then we get some number, which we usually call y. And so what an inverse function does, it goes backwards. Say if we're given our y, it tells us the x value we need to plug in. So an inverse function is usually written like this, f inverse. Maybe we could put y on the inside. So this is telling us, so this relation, they're related like this. So if f of x is equal to y, then f inverse of y is equal to x. So basically, like maybe just, a quick little example. Say if we have an equation, f of x is equal to x plus 3. And we see that f of 3 is equal to 6. But what the inverse function is, so what if we were just given this piece only? We know f of 3 is equal to 6. Or no, maybe how we want to say it is what this function does, f of x, we see that if we plug in 3, we get 6. So one way of saying that is we know we can plug in 3, we plug it in the equation, we plug it into f of x, and then we get 6. But how about if the question asked, what is the x value? Such that f of x is equal to 6. So this is what the f inverse function solves. Well, all we have to do is plug 6 into the s inverse function. So we would get f inverse, we plug in 6, and then this would end up equaling 3. But so the only way we would know this is we have to calculate the f inverse function. So there's a certain way to do that. So now what we need to do is need to calculate f inverse of x, or f inverse of y. It doesn't really matter. That variable can change. We can put a y in there. So basically what the steps are, so say if we're given, let's just do it by examples. Let's start with, I guess 45. So for the following, we just want to find f inverse. Let's write that up here. All right, so 45, we're given that f of x is equal to x plus 4. So what the steps are is the very first step is always to replace f of x with y, meaning instead of writing f of x is equal to x plus 4, let's write y is equal to x plus 4. Then the next step, what we're going to do is we want to solve for x, meaning we want to get x equals something. So all we need to do really on this one is subtract the 4 over. So here we get x is equal to y minus 4. And then once you do that, this piece right here, this is f inverse of y. And so basically what that means is all we do is we replace x with f inverse of y. So here what we get is f inverse of y is going to be equal to y minus 4. So remember how we said f of x is equal to y, f inverse of y is equal to x. So once we just get x is equal to something, well, x if we look up here, x is the same thing as f inverse of y. So once we solve for x, we just replace that with f inverse of y. And so then we get our answer down here. So this one was a very quick one. Let's do another one. Let's do 46. So this one is f of x is equal to 7 minus x. So the first step is always replace f of x with y. So we have y is equal to 7 minus x. And now we need to solve for x. So what we could do is add the x over. So we get y plus x is equal to 7. Then we can subtract the y over. X is equal to 7 minus y. And remember, f inverse of y is equal to x. So all we do is replace this x with f inverse of y now. So what we get is f inverse of y is equal to 7 minus y. Okay, 48. So f of x is equal to 5x plus 8. So again, the first step, replace f of x with y. So y is equal to 5x plus 8. Now we need to solve for x. So we can subtract the 8 over. Y minus 8 is equal to 5x. And then divide the 5 to the other side. Y minus 8 divided by 5 is equal to x. And again, x means the same thing as f inverse of y. X is equal to f inverse of y. So all we do is replace this x with f inverse of y. So we have f inverse of y is equal to y minus 8 all over 5. Let's do 50. So here we're given f of x is equal to minus 3 over x. So we have y is equal to minus 3 over x. So we can multiply the x over. Xy is equal to minus 3. Now divide by the y. X is equal to minus 3 over y. And then we're good. So again, x is equal to f inverse of y. So we solve for x now. We replace this x with f inverse of y. So we have f inverse of y is equal to minus 3 over y. Do 52. So this one is f of x is equal to 5x minus 3 all over 2x plus 1. So the first step, we have y is equal to 5x minus 3 all over 2x plus 1. And now we need to solve for x. So the first step to do here is we need to multiply 2x plus 1 on the left, or on the right. And then we have to do 2x plus 1 on the left. So on the right-hand side, it's going to cancel. And then on the left-hand side, we distribute. We'd have 2xy plus y. And then so on the right-hand side, it cancels. So we just have 5x minus 3. Cancels, cancels. Okay, so remember, we have to solve for x. So let's get x on the same side and everything else on the other side. So let's subtract that 5x over to the left. So 2xy minus 5x. And then this y, let's move it over to the right-hand side. So we'd have minus y minus 3. And now, so again, we want to solve for x. So let's factor out the x on the left-hand side. So we have x, then 2y minus 5 is equal to minus y minus 3. Now let's divide that 2y minus 5 over. X is equal to minus y minus 3 divided by 2y minus 5. And then we're good. We solve for x. We know x is equal to f inverse of y. So our inverse function is f inverse of y is equal to minus y minus 3 over 2y minus 5. So So again, we made that comment before where, you know, we have this relation. If f inverse, or sorry, if f of x is equal to y, then f inverse of y is equal to x. So look at this problem up here. We've given that f of x is, let's just write it down again. F of x was equal to 5x minus 3 all over 2x plus 1. So notice that we can, you know, plug in values for x. How about f of 2? So if we plug in 2, what we get is 10 minus 3 all over 4 plus 1. So that's going to be 7 over 5. So what this tells us is then, so we plugged in 2, and we plugged in 2, and then we get 7 over 5. So that's going to be our y. So over here, if we didn't make a mistake, we would need to plug in 7 over 5 over here and see if we get 2. So let's see if that's actually the case. So if we find f inverse of 7 over 5, we need to get the number 2. So let's just plug that into f inverse to see what happens. So we would get minus 7 over 5 minus 3 all over 2 times 7 over 5 minus 5. So do some simplifying here. So the common denominator is going to be 5. So we would get, so it'd be minus 15, minus 22 over 5, right? Because that would become 15 over 5. So 7. Yeah, that's good. And on the bottom here we would have, so 14 over 5, then minus 25 over 5. Okay, so minus 22 over 5. So 14, is that minus 11 over 5? And so what this ends up equaling is the top fraction. So those two minus signs, they go away. So we have, when we divide by fractions, we take our top fraction and multiply it by the bottom fraction turned upside down. So here the 5's cancel and we just have 22 over 11, which is equal to 2. So we do get f inverse of 7 over 5 is equal to 2. And that's what we needed. So we need f, because over here we see we have f of 2 is equal to 7 over 5. And here we have f inverse of 7 over 5 is equal to 2. Like they always have to be backwards of each other. So this piece is right here, and this piece is right here. Okay, how about 54? So we have f of x is equal to x plus 5 to the 3. Okay, so we start, we have y is equal to x plus 5 to the 3. Then what we want to do to solve for x here, we're going to take the 1/3 power of both sides. So take the 1/3 power of this, take the 1/3 power of this. So on the left-hand side, we just have y to the 1/3. And over here, those 3 and the 1/3 cancel, so we just have x plus 5. And we can subtract the 5 over. So y to the 1/3 minus 5 is equal to x. Again, f inverse of y is the same thing as x. So what this is telling us is that f inverse of y is equal to y to the 1/3 minus 5. Okay. The last ones do, actually that's good. So one last thing from this section is, does this book even talk about it? No, we don't need to do this. Oh yeah, it does talk about it. So it's called the inverse function property. So what this is telling us is this. F is the inverse of G if f composed with g of x, so if we plug g inside of, actually let's use the full notation. So two things. So either of these, they're the same thing. So f composed with g of x is equal to x, or g composed with f of x is equal to x. So both of these things. So let's go do just a couple examples with this. So suppose we're given f of x is equal to 3 over x plus 1. And what we want to do is let's find f inverse of x and use the inverse function property to check our answer. All right, so we start finding the inverse function. So we have y is equal to 3 over x plus 1. So if we multiply the x plus 1 over and divide by 3, what we get is x plus 1 is equal to 3 over y. We could subtract the 1 over. X is equal to 3 over y minus 1. So we have f inverse of y is equal to 3 over y minus 1. So now let's figure out what is, so remember another way, right? We can just, this variable here, it does not really matter. All it is a placeholder. So another way of saying this is f inverse of x is equal to 3 over y, 3 over x minus 1. Remember that variable, the y, it doesn't really matter what it is. All this is telling us is if we put a number here, that number goes here. So if we put an x right here, then we just put an x down here. Okay, now let's see if we made if this is actually is the right, let's use the inverse function property to see if we didn't make a mistake. So what we need to have, so we need f to be, when composed with f inverse of x, this needs to equal x. So this is, one of the, we're doing either, we don't need to do both of these, just one of them's fine. So we just have to compose the two functions and see if we end up getting x. So let's see what happens. What does this equal? Well, f composed with f inverse of x, this is equal to f, and we're plugging f inverse on the inside. All right. F of x is 3 over x plus 1. So if we plug in f inverse of x, we're going to get 3 over f inverse of x plus 1. Again, remember, so f of x is at the top of the page up here. So whatever goes on the inside of the parentheses, we just plug it down here. Now on the inside of the parentheses is this f inverse of x. So we're plugging the f inverse of x in on the bottom. Okay, so what is f inverse of x? We have 3. F inverse of x, we calculated it right here. That is, well, we're using f inverse of x, so let's use this one. That is going to be 3 over x minus 1. So we have 3 over x minus 1, and there's still this plus 1. Okay, so now on the bottom we have that plus 1 minus 1, so that goes away. So we have 3 over x. So this is equal to the top. So the top is just 3, and then we divide by fractions. You take the bottom fraction, turn it upside down, x over 3. So the 3's cancel, we just get x. So we're good. We do end up getting that f composed with f inverse of x is actually equal to x. So that's really all we needed to do. So this really isn't anything new. We did composite functions a little bit ago. This is just like a way to check your answer. Okay. The last thing from this section let's talk about is the domain and how they relate. So the domain of the inverse versus the domain of the regular. This would be like some domain things. So the domain of f of x is going to be equal to the range of f inverse of x. So remember the range, that just means the y values, and the domain means the x values. And then it's backwards. So the range of f of x This is the domain of f inverse of x. So we've had techniques to find the domain. We never talked about the range before because usually finding the range is quite hard. It's not really possible to do. But so say if we want to find the range of f of x, well, one way to do that is can we find f inverse of x and then just find the domain of it. So finding the domain is always easy. There's always like a sequence of steps you follow, but finding the range can be kind of hard. So for example, say if we want to do something like find the range of f of x is equal to about x minus 1 to the third power. All right, let's actually do, let's see, how can we do one of these? How about x plus 1 over x minus 1? So let's find the range of this. So again, we don't really know how to find the range, but we can use this property up here where we know the range of f of x is the domain of f inverse of x. So all we really need to do is just find f inverse of x and then find the domain of it. So the first step we're going to do is, so find the range of this. So since we can't find the range directly, let's call this one, or just put these little bullet points up here. We are going to find f inverse of x and then find the domain of f inverse of x and use the relation the range of f of x is the domain of f inverse of x. Okay, so first let's find f inverse of x. So we have y is equal to x plus 1 over x minus 1. So we need to solve for x. Let's multiply that x minus 1 over to the left-hand side. So y times x minus 1 is equal to x plus 1. So now we need to distribute. We have yx minus y is equal to x plus 1. Okay, so now we need to get the x's on the same side because we have to solve for x. So we're going to have yx, we'll subtract that one x, so minus x. We move this x over to the left, and we're going to move this y over to the right. So y plus 1. Then we could factor out an x, y minus 1, and then divide by that y minus 1. Okay, so what we have here is that f inverse of y is equal to y plus 1 over y minus 1. So we have our inverse function now. Let's make sure we didn't make any mistakes. Everything looks good. So now what we need to do is find the domain of this. So remember the domain, so we need to think about fractions and square roots. There's no square roots here, but we do have fractions, and we can't have the bottom of our fraction being 0. So y minus 1 can't equal to 0. So y is not equal to 1. So our domain is going to be this. Here's 1, can't be 1, so we get rid of it, but everything else is okay. So the domain of f inverse of y is equal to minus infinity to 1, 1 to infinity. But at the same time, that's the same thing as this equals the range of f of x. So we're done here. We found that our range of f of x is going to be minus infinity to 1 and then 1 to infinity. Okay. It's good from that section. Let's move on to section 5.2. Let's see. There's really only one problem from this section. So this is just doing graphs and we're doing more transformations and stuff. So the only difference now is we're doing the exponential function. So for example, we have two options. So this is going to be for f of x is equal to a to the x, and a is some number. So we have two options here. The first option is going to look like this. So the graph never gets to zero. So in this direction, it gets really, really close to the x-axis, but it never touches it. And the graph moves up to infinity on the other side. And always this is going to be the point 0, 1. And so let's say this is, so f of x is equal to a to the x, and here a is going to be a number bigger than 1. And then always this is going to be the point, so this is going to be 1, so 1 comma a. So that point is always on the graph. So we always have the point 0, 1 and the point 1 comma a. The other option, it goes the other way. And here's f of x equal to a to the x. And then here, a is in between 0 and 1. So like 1/2 or 1/3, something like that. And so what we have over here is still the point 0, 1. And then we have this point over here, same thing. We still have the point 1 comma a. Let's put a 1 down there. All right, so those 2 points. So these are just the two, we can call these kind of like the parent function. So this is the parent function of an exponential function, so a to the x. And then there's one special case. And this is going to be f of x is equal to e to the x. And e is just it's a number. It's e is equal to 2.71, and it goes on forever and ever, and it doesn't repeat. But all that matters is that e is bigger than 1. So the graph is going to look like this one over here. So what e to the x looks like, it moves up like this. It's got the point, so here's 0, 1, and it has the point 1 comma e. Because before we had the point 1 comma a, but now that a is equal to e. So we have 1 comma e. So all that's really important is from the section is just knowing what the general shape of these graphs look like. So like, for example, let's say, we're going to graph the following. Using transformations. So this one will be 34. Okay, so 2x minus 1 minus 3. So remember, using transformations, we start with our parent function. So the parent function here is it's going to be 2 to the x. Then our first transformation, the thing that happens closest to x, is going to be 2 to the x minus 1. And the last thing is going to be 2 to the x minus 1 minus 3. So we start by graphing our parent function, 2 to the x. So 2 is bigger than 1, so the parent function is going to look like this. We have the point 0, 1, and we have the point 1 comma 2. So here's 2 to the x. Our next one, 2 to the x minus 1. So remember, if we subtract 1 to the x, if we subtract 1 to the x, that means we move the graph over to the right. So this point 0, 1 now is going to be at 1, 1. And this point 1, 2 is now going to be over at 2, 2. We move everything over to the right. So now the graph looks like this. So it's still sort of the same shape. Just everything gets shifted over to the right. And then the last one, so now we're subtracting 3 on the outside of the x. It means everything gets moved down 3 units. So first, remember, this graph, it got really close to the x-axis, but it never touched the x-axis. But if we move everything down 3 units, now it's going to get really close to this line down here at y is equal to minus 3. So we have to keep that in mind. We have to move the asymptote down. Let's erase all this red. So when we move the graph down 3 units, now we're going to have this asymptote down here at minus 3. So move everything down 3 units. This point gets moved down 3 units, so now it's going to be at 0, minus 2. Sorry, 1 second. Sorry about that. I'm at my mom's house and she has like this little parakeet and it was like chirping too much. Okay, where are we at? 2x minus 3, or sorry, 2x minus 1 minus 3. So everything gets moved down through 3 units. So we take this point up here. Where are we at? Sorry, no, there is no 0 minus 2. We were looking at the wrong graph. Remember, because we go to this graph and then we move down to this graph. So we move everything down 3 units from this graph right here. So we're going to take this point, this 1, 1, we're going to move that down 3 units. So now that's going to be over at 1 minus 2. Where are we going to put this point? Let's try to erase this little dot. Okay. So let's see. How do I write this in here? 1 comma minus 2. And then this point gets moved down 3 units. So now it's going to be at 2 minus 1. And then the graph just does this. So the same shape, but everything just gets moved down. So this will be our final answer. All right, let's do some more examples. I'm just going to make some up because the book doesn't have too many. How about let's just do f of x is equal to 3 times, or let's do it like, how do we want to write this? Yeah, so 2x minus, or it says do 2x plus 1 and then plus 1. So, okay, what's the parent function here? Oh, we did 2 to the x last time. Let's do 4 to the x. So our parent function is going to be 4 to the x. Our first transformation is going to be then the 4 to the x plus 1. The second is going to be multiplying that 3 into the front. And then the third thing is the plus 1 at the very end. All right, so let's start with the parent function. So 4 to the x, we have 4 is bigger than 1, so it just looks like this. We got 0, 1. And then we got 1, 4. Okay, so our next one, 4 to the x plus 1. So that plus 1 means everything gets moved over to the left now. So we have 4 to the x plus 1. Everything gets moved over to the left, 1 unit. So this is going to be at minus 1, 1. And now we're going to have the other point's going to be at 0, 4. So again, this point gets moved over to the left 1 unit, and we move this one over to the left 1 unit. So it's still the same shape. Let's move this guy over. Okay, so our next one, let's move down over here. The 3 attached to the front, so our third transformation. So we had the 3, 4 to the x plus 1. Okay, so remember that 3, if we multiply a 3 on the outside of everything, that means we multiply all of our y values by that. So over here, we're going to take this y value of 1, multiply it by 3. So now it's going to be a minus 1, 3. Take this y value, which is 4, multiply it by 3. Now it's going to be at 0, 12. So now we also think about, let's think about this asymptote. The asymptote is at a y value of 0 right now. We're not adding 3, so it's not going to move up 3 units. It's actually not going to change at all. Since the y value is 0, if we multiply 3 by 0, nothing changes. So the asymptote, when we do multiplication, like in this step right now, it's not going to change. So again, you can think of the asymptote, the x-axis, is the line y is equal to 0. So what we said is when we multiply a 3 on the outside, we multiply all the y's by that number being 3. So we multiply all of our y's by 3. But on the asymptote, every y value is 0. So 0 times 3 is 0. So the asymptote actually still stays at the x-axis. So the graph looks like that. Okay. And then our last one. What happened here? Let me try to draw this a little bit neater. Okay. And then our last one, we have the plus 1. So 3 x plus 1 plus 1. So the plus 1 on the outside means we take all of our y values and we add 1. So now we are going to change our asymptote. So our previous asymptote is at the line y is equal to 0, the x-axis. If we add 1, everything gets moved up. So now our new asymptote is going to be on this dotted line at y is equal to 1. So those are our new asymptote. And all the points gets moved up. So that 0, 12 point, now it's going to be at 0, 13. And the minus 1, 3, now it's going to be at minus 1, 4. So we connect the dots, and then this shape right here, this will be our answer. Okay. Let's just move this up a little bit. All right. What else do we need to do? How about one more from the section? Let's do f of x is equal to 1/2 x minus 2 plus 3. So our parent function is 1/2 to the x. The first transformation, 1/2 to the x minus 2. And the second transformation, 1/2 to the x minus 2 plus 3. So starting with our parent function, so now we have 1/2 to the x. So 1/2 is in between 0 and 1. So the graph is going to look like this. So we have this point over here, 0, 1. And then we have this point right here, 1, 1/2. All right, so there's 1/2 to the x. Now let's do the first transformation. So to the x minus 2. So x minus 2 means we move everything over to the right. So we're going to move the 0, 1 point over to the right. Now it's going to be at 2, 1. We move 1/2, 2, so 1, 1/2 over to the right. Now that's going to be at 3, 1/2. So we're moving every point over to the right 2 units. So then what we have, it looks like this. Okay. And then the last one, the plus 3. Okay, so now every point gets moved up 3 units. So remember, before we had the asymptote on the line, the x-axis. But if we move everything up 3 units, that asymptote is going to move up 3 units. And now we take all of our other points, move them up 3 units. So this one gets moved up 3 units. So now it's going to be at 2, 4. And this one gets moved up 3 units. So that one is going to be at 3. And if we add 1/2 plus 3, that's going to be 7/2. Then connect those dots. Okay, and so this will be our final answer. All right, let me make sure it's everything from this section. Yeah, that's a good place to end it for today. So I'll put this video up on YouTube right now. And also I'll put the homework up. So homework for chapter 8 and chapter 5, I'll put that up within like the next hour as well too. Okay, yeah, so that's all we got to do for today. So thank you. I'll see you guys tomorrow. Thank you.